With this session, we are going to see how serial connections are confirmed to have properly connected and see what are the commands that helps us that it has established a successful connectivity. For this experiment, I have used routers along with the switches. The two routers named here R1 and R2 are connected with the end switches. So for any of the Cisco device connectivity to get verified, we can use CDP. So in default, the CDP will be enabled. CDP is elaborated as Cisco Discovery Protocol. So defaultly, even if it is a switch or a router, the CDP is enabled. Show CDP neighbor helps us to know that R1 is enabled. So R1 is the one which is with which switch 1 is connected. Now you can see that R1 here. When I get into R1, it should have two neighbors. Show CDP neighbor. But here you can see that switch 1 is connected with the model name 2960 along with first Ethernet 0. If I hover my mouse over to the device, it helps me to know for which device it's been enabled. For this option, you can have options to always show ports label face, which enable to know the interface details over the topology. In case you not want, you can uncheck. This has several options to work and play around with this options. Now moving into uh, debugging on what happens with the CDP neighborship not forming between R1 and R2. So, as per instruction, it's been informed that there is a DCE and DTE, digital communication equipment, digital terminal equipment. So, we can see these things, terminologies used in serial connectivity. It's not as used with Ethernet. We all know that Ethernet directly have each port mapped to TX RX and data as well. It has four pair of cables for Ethernet to have the two cables used for TX and RX and another two is used for data. Whereas in serial cable, similarly we have an option of transmission and receiver and data. As we all here deals with signals and it depends on type of day or rate of data transfer. Here it's very important to know the clock rate because it all sends over electrical signals over the serial cable. So we they have a standard protocol procedure stating that to check the DCE clock rate and DTE clock rate to get matched. So it's not even should we get matched. You can moderate the data traffic as per the topology wish. So in this case, as instructed, we here to configure 64 kbps for DC. It's not mandatory that both should be matched. So I am getting into DCE of R1. For that, you can so it confirms who are connected, but we need one more details. So we'll see the running configuration happened with the serial interface. So this case serial as using a clock rate of 2000 megahertz. Here also it's 2000. It's already been matched, but we can moderate as per our wish, as I said. So in this case, we are going to try experimenting DCE to set higher bandwidth in kbps. We can also get to know about DCE and interface details. Serial interface, serial 0, right? Show interface. You can see here it's administratively down and protocol is down. We have a command. We won't see able to see DCE and DTE in this interface list. We need to get into the controller. Show controller will help us to know the counters and everything. Along with that, DCE DTE will also be listed. Yeah, for interface serial 0, you can see that the hardware uses its power quick MPC microprocessor controller 860. It's having a DC equipment V.35 and clock rate is as per the configuration it has taken. We can ex- extensive into 64 kbps. Here it's all referred with bits per second. Let's go here and do it. Clock rate and see it's all in bits per second. So we have this configured. We have options to choose 64 kbps. So that's our requirement. So I'm going to give here 64 kbps. On doing this, I'm able to see that change it to 64 kbps. So moving further, I can set in the neighbor connecting device the same DCE won't be there. Serial 0. So here it will be DTE. So you should clearly have an understanding. In serial, one will be a DCE and another will be a terminal equipment. So ideally, If you change a clock rate, automatically synchronized. That's the beauty of this. And you can enable now the IP configurations on the main reason for the link is down is it is in shutdown state. That's the reason. When I give a no shutdown, automatically it all will be up. But still the protocol would be down. Why? Because we don't have any IP configuration. So we need an IP to get configured between the L3 device. As this routers are L3 device, we need an IP address 192.168.0.1 255.255.255.0. No shit. And moving to R2, conf t interface serial 0 IP address 192.168.0.2 254 255.0. No shit. I have now brought the link up. You can see that green color started growing. So I'm able to see that then CDP neighbor should also be formed once you the state connected links are up. So it clearly confirms that we could able to establish. And when you get into this controller, you can see the DCE clock rate changed to 64,400 64,000 kbps. So now let's do a ping between the routers to test the connectivity. 192.168.0.2. It will ping successfully. In addition to that, if you want to see serial 0, automatically it should detect that clock rate and list here. Think it is not listed. Clock rate detected. And ideally, we have running configure with 220,000. See, it is not been configurable. One more important thing is DCE is only configurable, DT is not configurable. So we could achieve that R1 type configurations. CDP neighbor, CDP neighborship, and even with R2, you can see that show CDP neighbor. Two devices were connected. So if for any connectivity check, CDP helps. In case it is not, we have alternative like LLDPs. But as per this topology, we here tested with CDP for connectivity.